Okay, good morning. So let us continue the lesson. In this lesson, I just want to give you some examples of what we had before. A little bit harder examples. I see that some of them were in national tests, so let us try to practice a little bit more on this topic. So I will solve more or less all the equations by myself so that you can get a little bit of time if you have any questions regarding the exam and everything. Well, we can finalize, but I cannot promise. Let us see how it goes. We have a function is given to us. The graph actually is given. Something like that. And this point is given to be 6. This point is given to be A. And this area is given. This function is also given. F of x is equal to 7 over 3x plus 6. Yes? Yeah. Oh, sorry, this is not A, this is E, the Euler number. Yes. And the area is given to you. Area is given to be this number, 7 over 3 ln of 4. Area units. We want to calculate the exact value for A. So the exact value of this number A is wanted. Yes. So we know if I want to find the area, so you shouldn't reverse the logic. You want to calculate the area. So the area is, let me call it capital A for the area. So area is equal to the integral from E to A of your function 7 over 3x plus 6 dx. Yes? So if I want to calculate the area, according to what we learned before, I have to calculate this integral. I don't need to be worried about the negative sign because the whole part of this is above the x-axis. So if I myself want to calculate the area, I have to write this. On the other hand, they have given me the area. So this means that if I calculate this integral, the result that I get should be that number. By equating these two, then probably I can find this unknown. Something like this we had in national exam. So you need to be a little bit observant, because if I want to calculate the integral, the only thing that I have in my hand is Newton's formula. So I have to be able to find a primitive function for this function. I don't know if you remember or not, but when I was teaching you the topic of primitive functions, I also told you that some harder problems uses this rule. So let me just remind you of that. That's also good for today's exam. Do you remember what is the derivative of ln? The derivative of ln, if u is a function of x itself, becomes u prime divided by u. Yes? That is probably you are very familiar with because of today's exam, tomorrow's exam. But this one, the other way around, you need to understand this. So if I want to differentiate, I go in this direction. This combination, you should have it somewhere in your memory. If I have a fraction, so that the numerator is the derivative of the denominator, it means that its primitive function is ln of u. So if you want, I can write it like this. A primitive function for this combination u prime over u is ln of absolute value of u. And that's exactly the reason, because the derivative of ln of u, or the absolute value of u, by the way, you know that there is no difference. We proved both of them. If I start with ln of u, then I have to make sure that u is positive. But if I start with ln of absolute value of u, u can be positive and negative, but cannot be 0. So the restriction is less. Okay, so now you might say that, okay, this is not of that type. Because if I ask you what is the derivative of the denominator, you say it becomes 3, but the number is 7. But fixing that is not hard, yes? So what I can do, I can write it in this form. I can write it as 3x plus 6. Instead of 7, I write 3, but I have to make it up, yes? I want to return it back to 7. How can I do that? By multiplying it by 7 over 3. Yes? If I multiply this fraction by 7 over 3, it becomes exactly the same thing. It goes from e to a dx. But now you know that one of the properties of the integrals is that if you have a multiplicative constant, you can pull it out. So 7 over 3 is a constant. I pull it out, and then I would write e to a. And then I hope that you agree with me. This can be written exactly in that combination, yes? Yes? Because if I ask you, what is the derivative of the denominator, it becomes exactly 3. It might be a little bit strange why I have written 3 in this way, but the reason, the motive behind that is because I want to make that combination right. Is that clear? Okay. Now, if I ask you, do I know a primitive function for the whole combination? The answer is ln of absolute value of u. So then it becomes 7 over 3 ln of absolute value of what appears in the denominator, yes? But you know that I have to calculate it from e to a, yes? And then let us just calculate it. So what happens? It becomes 7 over 3. I replace x everywhere with a. So what happens? It becomes ln of absolute value of 3a plus 6. And then minus, if you don't mind, I can factor of 7 over 3 out. And I put e instead. Yes? This is the answer to my integral. So what can I do? Do you remember there is a formula for ln? If I have ln of some number minus ln of another number, I can write 1 ln provided that I divide these two. So I can write it like this. So this becomes 7 over, so let me write the area, so therefore the area is 7 over 3 ln of absolute value of 3a plus 6 divided by 3ae plus 6. This is the area that I get, area units. Yes, is that clear? Okay, but do I really need absolute value here? No, because E is 2 point something, so it's positive. And according to the figure, EA is greater than E, so A is also positive. So don't get bothered with the absolute value sign. 3A plus 6 is positive, 3E plus 6 is also positive, so the fraction is positive, so I really don't need absolute value sign. I can replace it with pairs of brackets, yes? But this area is already given to you, so that should be equal to this, okay? So therefore, what I get is 7 over 3 ln of 3a plus 6, 3e plus 6 is equal to 7 over 3 ln of 4. Yes, is that understandable? Because the area was given to me from the beginning. I also calculated as usual, so these two numbers should match, so I get that equation. And this is probably fine-tuned in a way that you can get rid of this. And ln of something is equal to ln of 4, it means that this number is 4. Yes? So then it means that 3a plus 6 over 3e plus 6 is nothing except 4. But you are looking for the exact value of a, that's a very simple. Don't bother about this. This is just a number. So let us multiply everything by that number. It becomes 3a plus 6. I could also simplify that. I don't know why I didn't do that. So, of course, it doesn't matter, but I should have seen that before. So you can factor the 3 out, yes. So let me simplify. I factor a 3. Let me divide everything by 3. Yes, this becomes a plus 2, and then this becomes e plus 2 is equal to 4. And then I write a plus 2 is equal to 4e plus 8. And then I move 2 to the other side. And that is the exact value for the a that you were looking. And it was not impossible at all probably to guess that number. So that number is 4e plus 6. This is not exactly in the national exam, of course, but I have seen questions that you have to understand this combination somehow. Is that clear? Okay. So let me move to another example. So let me see. A graph is given to you, so let me... So you have, it is written, the colored region is the region between the graphs of the functions sine x and cosine, sine 2x. Okay, so this is one of them, of course in one period. Let me continue it. And then there is another one, which is this one. Of course this is not good because they have to have the same heights. So for example, like this, and then I clean it. So it hasn't even mentioned which one is which. It has written that this colored region this is the colored region discussed in the problem. They have written that the colored region is the region between the graphs of two functions y equals to sine x and the other one y equals to sine 2x. Determine the area of the colored region. So let me consider that A is the area, the total area. This is wanted. Okay? And this is the x-axis and this is the y-axis. So how should I do that? Which one is which? So if you remember what we learned in chapter 1, the period of this function is 2 pi, but the period of this function is 2 pi divided by 2. Yeah, so which is pi. And then it becomes clear that this one is sine 2x, but this one is sine x. Yes, because the period of sine 2x is half of the period of sine x. Yes? So then at least this becomes clear that this function is sine 2x, so that was up to you to decide, and this function is just a normal sine function. So what I am writing in blue is actually included in the solution. Okay, and then of course if I ask you, do you know this number? Probably you can answer what that number is. That is 2 pi. But there is another number which is relevant in this problem, which we don't know yet. And what number is that? Hopefully you can guess. This number is also needed. Because if I want to calculate the area, I have to calculate this area, that area, and then add them up. But this area is, of course, this area is between two curves. But in this part, the graph of sine is coming above. The graph of sine 2x is below it. But when I pass this threshold, the situation is reversed, yes? So I need to know this number, okay? How can I find that number? If I want to find the intersection between the curves, we have to solve a system of equations, yes? So I will set up a system. An equation is sine x, another equation is sine 2x, then I equate them. So when I equate them, it becomes sine 2x equals to sine x, and then try to solve this equation. If I solve this equation, then I am done, yes? You can solve it in two different ways. I don't know which one is easier. For example, you can say that two sines are equal. There are two scenarios, yes? Either the first one is equal to the second one plus 2n pi, n is an integer, or 2x is pi minus x plus 2n pi, again n is an integer. So here, this gives me that x is 2n pi. This gives me that, let me just do it in my head. I bring it here, it becomes 3x, and I divide by 3. So x becomes pi over 3 plus 2n pi over 3. These are the all possible intersection points, and I hope that you agree with me. They have infinitely many intersection points if I continue from the left and to the right. But I want this one. Which one is that, do you think? Can you read it from the formulas here? So this number is what? So there is no hope that I can get this using this. Because if I put integers, n0 gives me 0, n1 gives me 2 pi, which is one of them. 0 is one of them, yes? So if I start increasing n to positive and negative values, I get multiples of 2 pi. But this is not a multiple of 2 pi, yes? So there is no hope to get the question mark here using this formula, so I will get it from this one. And then you see that this is the smallest positive intersection point. So when I choose n equals to 0, I get pi over 3. So this number is now pi over 3. So you see that was up to you to decide which one is which, and that was up to you to solve and find pi over 3. And then everything probably will be simple from now on. Yes? So what can I do? Let me call this one area, so let me just write this. I will take this one, area 1, okay? So let me calculate area 1. For writing area number 1, I have to integrate from this number up to that number, which we got, 0 to pi over 3. But this is the area between two curves. So you remember I have to subtract the curves, but which one comes first? The one which is on top comes first. In this case, sine x, don't get confused. This curve is the sine curve. So here is the sine curve. So this becomes sine x minus the other one, which is sine 2x, and then dx. And let me calculate this. A primitive function for sine x is negative cosine x. A primitive function for this one is negative 1/2 cosine 2x, so it becomes positive 1/2 cosine 2x. And then I have to calculate this between 0 and pi over 3. So this means that I replace it with pi over 3. Let us do it in our head. Yes, I put pi over 3 here. It becomes minus 1/2. Okay, so let me write it. So it becomes minus cosine pi over 3. And then plus 1 over 2 cosine 2 pi over 3. And then I place it 0, minus cosine 0 plus 1/2 cosine 2 times 0, which is of course 0 again. But this is minus 1/2. Cosine 2 pi over 3 is, so the reason that it becomes minus 1/2 because cosine pi over 3 is positive 0.5, so it becomes negative, and cosine 2 pi over 3, so do you remember cosine 2 pi over 3 can be written as cosine pi minus pi over 3. So pi over 3 and 2 pi over 3 are supplementary angles, so it becomes negative again. So this becomes plus 1/2. Cosine of 2 pi over 3 is also negative 1/2. So hopefully I haven't done any mistakes. So this becomes minus 1/2 minus 1 over 4. So it becomes minus 3/4. Because you know that at the end, if I get a negative value for a, it means that I have done something wrong. But what is this one? This is negative 1 plus 1. It becomes negative 1 over 2. Yes? And then I go back to horizontal, I get this number on top minus this number below. So this becomes minus 3 over 4 plus 1 over 2, which is wrong, yes? Where did I make a mistake? Do you see that?
How do you feel that? Well back. In the graph, the larger or more oval shaped graph, isn't that sine x, not sine 2x?
Oh, I made a mistake there, you mean?
Because I use a calculator and it shows that.
No, so let me see. The period of sine x is 2 pi,
Yeah.
so, and that is one period, isn't it? And then the period of sine 2x
It's supposed to be
is
smaller.
pi, isn't it?
Yes.
Okay, so you are right. You are completely right. I messed up. It's not that late. That's good to see. You see, I don't know, for some reason I got this 2 pi. This is actually not 2 pi, yes? Yes, you are right. Thank you. This is the graph of sine. This is the graph of sine 2x. And this is the graph of sine x. So, that is not 2 pi. That is
Pi.
pi. But if that is pi, how is it possible that I get a pi there? Ah, yes, pi also comes from the second one. That is, so let me make sure that I am not doing something wrong. Yes, so that is, I really messed up, sorry for that. So here, the sine x has period 2 pi, and the period of this function is half of the period of that function. Yes, do you understand now? So I made it wrong, yeah. Thank you very much. So here, because you see, it was going wrong here. The number that I get at the end is negative, even though I was respecting that. So is that, first of all, is that understandable for everyone? That this one is sine. Yes, because you say that the period of sine is 2 times larger. If I ask you what is this one, this is half a period of one of these functions. And the half of the period of one function is the whole period of the other one. Yes? So then it becomes, this should be sine x, the other one should be sine 2x. Is that understandable? Sorry for that. Okay, so it means that it does not affect that much. It does not affect this one at all. Yes? This will affect this one a little bit, but I know how to. So this one should be written first. This one should be written second. Yes? And then what will happen, this becomes positive, this becomes negative. And then this becomes positive, this becomes negative. So then this becomes positive, this becomes negative, and then it becomes 1/2 plus 1 over 4, yes, which is positive 3 over 4. And then this becomes positive, this becomes negative, and then this becomes 1 minus 1/2, this becomes 1/2. And then when I go back to horizontal, when I go back to the horizontal, then I will get the positive value, hopefully this time. So this becomes the number on top minus the number below. But this is 2 over 4, so that is right. 1 over 4 area units. Thank you very much. Is that understandable? Yeah. And then I go to the area number 2. The integral will be the same, but this time, so let me raise the board a little bit so that we can see it. Yes. Now area number 2 is the other way around. Yes? Okay. So the area number 2 will be the integral. This time it starts from pi over 3 and goes to that point, which is a pi. Yes? And then what will happen, I will have the top function. This time the top function is sine x. The lower function is sine 2x, okay, and then dx. So you see, let me make it more clear here, there is a negative sign here. So in principle, I should have written them the other way around, but that's completely right in this way. And then a primitive function for sine this time is minus cosine, and this one becomes plus 1 over 2 cosine 2x. And then the whole expression goes from pi over 3 to pi. Yes. And then you put the numbers there. So cosine pi is negative 1, so it becomes positive 1. I put pi here, cosine 2 pi is 1. So it becomes 1 over 2. Yes, so it becomes 3 over 2. And then I put pi over 3 here. It becomes negative 1 over 2. And then if I put it here, negative 1 over 2 times 1 over 2 is 1 over 4. So it is minus 3 over 4. And then I go back to horizontal. So this becomes 6, 9 over 4. Okay, so area units. And the total area is what? Is 1 over 4 plus 9 over 4, which is 10 over 4, which is 5 over 2 area units. Okay, let us wait a little bit. Is Mike because of that messing up? Is everything clear now? Yes? Okay. This question is exactly from the national exam question 1997. Usually, I don't know what is the policy in Sweden. You know that if you want to do an exam, all past papers should be available if you want to practice. But because probably they don't want to do hard work, they keep it confidential. And every now and then they expose one of them. So at least 1997 is one of them, yes? So if you want to prepare for an exam, the most natural thing is to start working on the previous exam, yes? So determine the exact area. So this is the national proof, the spring term probably 1997. Determine the exact area of the region enclosed by y equals to square root of 2x plus 3 and y equals to x and the x-axis. So I don't know on which part of the exam this was. I haven't written something like that. It might be in the one that you are not allowed to use any calculators, or it might be on that part that you are allowed to use the calculator. Really, I don't know. Because if you are not allowed to use the calculator, it means that you have a good idea about sketching that region. Because if you don't sketch that region, it would be hard to solve the problem. Yes? Okay, so let me just a little bit wait for you. So here, the x-axis, I don't have any problems. That is the x-axis. The y equals to x is also very famous. That's the bisector of this. But what about this one? You don't need to be precise at all, but you should have a feeling about how to draw the graph. What type of graph? So for example, I don't know how many of you are familiar with the graph of this one. Because if you have something like this in your head, this is more or less the same thing. You see, that's just a shift. Yes? So that function can be written as 2x plus 3 over 2. And we already discussed about that. You see, x here has been replaced by x plus a number. So that just would be a shift. And this is positive, so that would be shift towards the negative values, if you remember. So mainly, I don't know if you have this function in your head, how to draw it. But even if you don't have it, probably you can get some numbers for a square root of x. If I put 0 for x, I get 0. If I put 1, I will get 1. But if I put 4, for example, I will get just 2, yes? So that would be something like that. Yes? So you really don't need to be very careful to waste time. But of course, if you want to do it properly, it should be tangent and goes like that. Yes? But anyway, that's not important. But then what happens for this one? The only point is that the zero of this function is here. The zero of that function is replaced a little bit, is shifted. What is the zero of this function? You put it 0, x becomes minus 3 over 2, which is minus 1.5. So the only thing is that the zero of that function is here. So if I put this number here, y becomes 0, so that is 1 point. For guidance, let me put x equals to 0. I get the square root of 3. So if I put 0, square root of 3 is somewhere like here. And then that would be the graph of my function. And I hope that you agree with me, there is nothing below the x-axis because y is non-negative, it's the square root. So that is enough, I would say, for sketching this region. So which region is wanted? The region bounded between these two and the x-axis. So hopefully you agree with me that this is the area that I am supposed to calculate. Yes? But this problem is hard from one perspective. How do you think that I have to break? This is a good problem. Because in this problem, apparently immediately you detect that you have two separate regions. So it was more or less trivial to find this and that and add them. But do you think that there is one piece of area here or two pieces? Clearly it's one piece of area, but I cannot solve it by one integral. Why is that? Can you tell me? Because, so you see, first of all, this number is wanted. We can immediately calculate that. How? I intersect these two to find this point. So let us do that. For finding this, I equate these two and try to solve the equation, but you know how to solve this is a root equation. When I square it, it becomes 2x plus 3 is x squared. Let me move everything to the other side. It becomes x squared minus 2x minus 3 equals to 0. If you use PQ or ABC formula, you will get two numbers. One of them is minus 1, the other one is what? 3. But of course, one of them is a false root. Minus 1 is a false root because if I put minus 1 here, the left-hand side becomes 1, the right-hand side becomes minus 1, which is not correct. So that is a false root. And this is the only acceptable answer. And let us check it. 2 times 3 plus 3, which is 9. Square root of 9 is 3. So that's correct. So this number that I was looking for is now clear. It is 3. Okay, but if you want to set up an integral, how should I set up the integral? I don't know. I want to wait a little bit here for you. Can I write one integral to calculate this area or not? Okay, let us see. If you are in this region, the area is between the x-axis and this curve. So this part, the area is below this curve, is under this curve. But when I pass this threshold, this area is no longer below this. It is below this one, but above this one. So this part becomes the area between two curves. Yes? So this is extremely important. If I want to find the total area, what should I do? I should write integral from this number to 0. But for which function? This function. Yes, which is the square root of 2x plus 3 dx. And then plus, okay, can you write the second integral for me? So now, if I ask you what is this integral represents this area. I want you to make sure that you really understand why this is going. But if I pass this threshold, then I go to a region which is bounded by two functions, not with the function and the x-axis. So what I have to write here, can you tell me? Yes?
So the integral of the same function from 0 to 3, and then you subtract it by because it's a straight line. The other function, it's a right angle triangle.
Don't confuse yourself. That is possible. What you are proposing is correct, but you don't need to do that, because this is the area between. Might be I am wrong when I say between two curves. I should say between two functions, and it doesn't matter if that function is actually a straight line. So this area that you see is between two functions, and then you write the function above minus the function below.
I know, but I wanted to avoid the integral for that function.
No, you cannot avoid, can you? If you can avoid, that is of course better, but I don't see any way that you can avoid. If you don't understand, let us discuss about that part. So you wanted to do what? You wanted to calculate this area. Yes, is that possible?
Yeah, and then subtract it by...
By that right angle triangle.
Yeah.
That is also possible, but the hard part is left. Because the hard part, I understand what you mean, that is very good you think in this way. So the hard part is actually not... So if you have to write this minus the area of that right angle triangle. But the area of, because you see that finding a primitive function for x is not the hard part. You are avoiding that part, which is of course correct. But finding a primitive function for this is the hard part, which we cannot avoid. Yes? By the way, I don't know what was the intention when they have written this question. If you want to calculate this is a very lengthy calculation. So because it is not trivial, by the way, how do you find a primitive function for this? It's not hard, it's a very simple trivial problem, but it is not systematically treated in the high school. So you need a substitution method to be able to calculate. I can describe it in a way that you understand it. If you calculate this, and these numbers are different, unfortunately, from these numbers. So you have to do it again for this one, and that one is the previous one. If you manage to calculate all of them, it becomes simple, and then you can calculate. Okay, I don't want to spend time on it because I want to change my strategy. I hope that you can understand that. At least I want to explain it for you. This is one way, but it is very lengthy. If you want, we don't have that much time. We can spend some time on calculating. At least I will give you some ideas how to calculate a primitive function. But for the time being, let us leave this one and change our strategy. What is the strategy that I want to describe? Instead of looking at the area vertically, let us look at the area horizontally. Yes? If I look at the area horizontally, then I don't have that problem that I have to split the integral into the region into two parts. Why is that? Because if I look at the area horizontally, this region is always bounded by two functions. This function and that function. Do you agree? Because you see, when I am here, I am between these two functions. When I am a little bit above, still I am between these two. When I am here, I am between these two. Here, between these two. You see, I don't have any discontinuity. That is the area between this line and this curve. Is that understandable? Is that understandable or not? Yes or no?
Yeah.
Because you see, if I wanted to do it vertically, let me just draw it. So let me just draw it here for you. You can see it here. Sorry. So here we have this. In this scenario, if I am here, this line is between this curve and the x-axis. If I go a little bit further, still the same. Between the curve and the x-axis. A little bit between the x-axis and the curve. But after this, the line is not between the curve and the x-axis, it is between two functions. So it means that I have to, if I want to look at the problem vertically, if I want to write an integral, I have to write it in this way, no one else. So this is the only thing. But if I change my perspective, look at the problem horizontally, it is always between this line and that curve, no matter where in the region I am. Yes? Is that understandable? But the point is that might be this is a little bit unusual. And when I look vertically, we write y in terms of x. when I look at it horizontally, I should write x in terms of y. Which one is very simple. I really don't need to do anything at all. So I write x equals to y. But this one, I can just do a little bit of calculation. So y is equal to square root of 2x plus 3. I want to write x in terms of y. So this becomes y squared. This becomes 2x plus 3. I move 3 to the other side. So it becomes 2x equals to y squared minus 3. And then x becomes 1/2 y squared minus 3/2. I hope that you are not getting confused. I'm interchanging by, instead of looking vertically, this is my y-axis, this is my x-axis. When I look it in that direction, this becomes my new y-axis, this becomes my new x-axis. So then I have two functions. One function is x equals to y, and the other function is x equals to this number. Okay, now can you set up an integral for me? I want to make sure that you understand what's going on. So, can you write an integral for this area by this change the strategy? Okay, so can you tell me what should I write? First of all, so I write an integral. Can you write, what should I write? Instead of dx, I should write, because now which one is my variable? Y is my variable. So I write dy. Okay, can you tell me the limits? You need to look it in this way. What is the lower y limit? 0. And it goes up to this highest point. Okay, so this is 0. What is that highest point? Can you tell me what is that highest point? Don't get confused. This square root of 3 was this point. What is this point? Say something. What is that number? So this point, you should be very quick in these things, yes?
It's 3.
It's 3, yes. Because this lies on this line. When the x is 3, the y should also be 3. So it goes from 0 to 3. Now, the function above is this direction, is this function, yes? Which is y minus the function below is this function. But this function is this function. Yes? So it becomes minus 1/2 y squared and plus 3 over 2. Now look, this integral is a Mat 3C problem. Yes? Because the only difference is that instead of having letter x, I have letter y everywhere. And this is just one single integral. But if I want to calculate this, I have to calculate this one, which is not trivial. I have to suffer a little bit more to calculate this one. And then if I add, I should get the same answer. So calculating this integral is a minority. Writing the integral is important. I want to wait for you to digest the problem, and if you have questions, please let me know. Yeah, is that understandable? The only point is that instead of... So in other words, if you are not very happy with that, we can think in this way. You see, if I start rotating this, the function form is changed, but the area is not affected. So if I want to calculate the area, I can rotate my picture and then calculate the area. Yes? This is also another perspective to look at the same problem. So, if you calculate this integral, I want to wait for you to understand why I have written this one first and this one second. Do you see that when I look at the problem in this direction, which one is higher, which one is above? The straight line is above the other one. Yes? Because a straight line is towards the more bigger values of x. And this one is related to lower values of x. So I have to write the bigger function, bigger function minus the smaller function. And then in, yes? And let us calculate this. So a primitive function for y is what? Is 1/2 y squared. A primitive function for y squared. Am I allowed to do this? Yes, because my variable is y. A primitive function is 1/3 y cubed, so it becomes minus 1/6 y third, y to the third, and then I have 3/2 y. And then I have to calculate this from 0 to 3. The good point is that I don't need to bother about 0 at all, because when I replace y with 0, everything vanishes. And then I put 3 here, so it becomes 9/2. I put 3 here, 27/6, which is 9/2, and plus 9/2. And then I calculate, it becomes 9/2 area. Yes? Yes. Yeah, is that understandable? Okay, but let me ask you some question. Might be, I don't know, because this changing the perspective is not included in the book. I don't know they really mean you have to solve this integral or not. But, or might be because I have seen these kinds of things happen in national exam. The only thing that they expect you to write is this, and because calculator is allowed, you need to know how to put the integral in the calculator and get the answer. Because I saw a problem in the national exam, I wanted to test myself. When I was trying to solve it hard, I realized that, okay, this cannot be solved using high school mathematics. Then I realized that this is in the calculator part. So the only thing that you were supposed is to write the integral and put the whole integral into your calculator and get the answer. So this is also a very good experience. Remember, the people who have national exam, so might be you are able to put the whole expression in the, and that is actually possible. Because if they say that you are allowed to use the calculator, they don't restrict you which functions you can use, which functions you cannot use. Yes? So in that case, please try to use your calculator as much as you can. But let me just ask you one question to understand, because that is at the level of your knowledge, that is not hard. So can you guess a primitive function for this function? Because you know that if I give you this, this becomes, let me write, just forget about the limits for the time being. This is a matrix problem. Yes? If I ask you to find a primitive function for that, it becomes x to the power of 1/2, and then you know what to do. But can you tell me what can I do here? Can you, based on this, can you find a primitive function for this? You need to do a little bit of guesswork right here. So let me tell you, if I ask you what is a primitive function just for square root of x, you write as x to the power of 1/2. Then what is the answer? The answer is 1/1/2 plus 1. As usual, I am using this formula. Yes? And then for this one, you write this, x to the power of 1/2 plus 1. And then if you simplify that, it becomes 3/2. But the reversed one, it becomes 2/3. And then x to the power of 3/2. So if I ask you what is a primitive function of this, it is extremely simple matrix problem, and the answer is this. Now, using what is on the board now, can you discover the connection? First of all, you understand that this method is related, but you see, when I write it like this, then it seems a dead end. Yes? What I want to do. You need to guess a function. I cannot use this formula naively, because this formula is designed only and only for x, not for 2x plus 3. But if you understand what is going on, and if you remind yourself about the chain rule, might be you can tell me what a primitive function of this is. Oh, let me ask you in this way. I put 2/3. Instead of x, I put this one. Instead of, I put the power 3/2. Do you agree Or do you agree this one or not? Do you think that this is a primitive function for that? I am just using the analogy, you know. I am saying that the primitive function for this is this one. Let us try to write a primitive function to be this one. Everywhere that I see x, I replace it with 2x plus 3. Now I'm asking you, do you buy this, that this is indeed a primitive function for that? Let us check. How do you check that? You start, this is tomorrow's exam. You should be very good in calculating the derivative of this. So how can I calculate the derivative of this? Tell me. So what should I do? I take 2 over 3 out. This number goes down. And then I write 2x plus 3. I subtract 1 unit from it, which becomes 1/2. But should I stop there? What should I do? Is it finished here, the derivative?
Times 2.
Times 2 because of the chain rule. So now look. This one and that one are gone. And this is exactly what I want. With an extra 2. So this means that now you should be able to guess. So it was not very wrong. It is correct up to a factor. And then you know how to compensate for that factor. Now can you tell me at the end what would be a primitive function for this? Now you see everything on the board. If I start from here, at the end I will get an extra 2, which I don't need it. So I need to foresee that, to put something there to compensate for that extra factor. So can you tell me what should I write? Yes?
It's divided by 6.
No.
Divided by
2 divided by 6.
Yes.
Yes, I thought, okay. 2 divided by 6 means 1 over 3. Yes? So instead of having 2 over 3, what I have is only 1 over 3. I hope that you agree. If I have started from 1 over 3, I will not have that extra 2 at the end. And this is the way that you guess. So it means that it is not totally irrelevant to this one. It's not totally irrelevant to this one. But it's a little bit different, and that difference is just this one. So now, if I ask you, do you know how to calculate this integral? The answer is yes. Because you were able to find a primitive function for that, and that was 1/3 2x plus 3 to which power? To the power of 3 over 2. And then I calculated between these two limits, which is a trivial task to do. So anyway, I just want to tell you that this is not completely above high school, but this would be a very standard part of your studies when you want to study integrals at university, and that's called substitution method. But anyway, okay, but you see that sometimes in the national exam there are good questions, so that might be hard. Even it doesn't matter. If you want to do it a straight way, you have to understand this, and the calculation is very lengthy, or you have to be very clever to look at the problem in a different way, and that's also a hard question. So I would say that this is above probably the level of all questions that you have seen in the book. So you see, math for national exam is a little bit hard, okay? So you need to practice more, but don't worry about that much. Any questions here? Okay, because I don't want to okay, so let me give you one more example. So what is this area? We want to calculate this area. Sometimes they can just give you the region. So this is something like that. So these two lines, these are straight lines and they are parallel. Of course, they haven't told you that they are parallel. They have given you just the equations. And this curved region, the boundary is one part of the graph of this function. And then you're supposed to find the area of this shape. Yes? You want to find this area. This area. So this one is also included. So it is not a quadrilateral because this one is curved, but this one and that one and that one are the boundaries, and I have a curved boundary. Yes? We want to find the area that you see inside these boundaries. And the equations of these lines are given. Of course, immediately you see the k value is 1, the k value is 1, so you realize that they are actually indeed parallel. Okay, let us also solve this problem. So how do you think I can solve the problem? Can I write one single integral to represent this area of this region, or I have to break it up? Okay, my picture is motivating you. They are the same. So yeah, let me make it more clear. There is no guarantee. It might be or might not be. Okay, so I don't know. Apparently, I have done it with GeoGebra precisely, so it shows that this is not the case. So let me not confuse you. This is the way that it works. Might be. Okay, so okay, that's better now. And this is not given on a grid paper, so you have to do all the calculations yourself. So, yeah, that is a better picture. This is closer to the real one. Okay, just tell me, can I write one integral to represent this? Or I have to break the area, even though that is one single area? You see, here, if I am somewhere here, the area is between these two straight lines. Yes? But the situation changes at some point. Yes? When I reach to this point, before this vertical line, the region is bounded by these two functions. Yes? But when I pass this vertical line, the function is bounded between this function and the other function here. So this shows that if I want to just act as normal, just go horizontally, then look at the problem vertically, I have to divide the problem. And you cannot avoid this. Even if you look at it in this direction, the problem even becomes harder sometimes, yes? So I would look at the problem vertically, but I realize that I am allowed to go up to this point between these two functions, and after that I have to calculate between these two functions, the area between two functions, yes? So, but then I have to find this point. What that point is, I need to find the intersection between these two, yes? So what I do, I set up a system, y equals to x plus 2, y equals to 3 over x, and then I equate them. So 3 over x becomes x plus 2. I multiply everything by x, it becomes x squared plus 2x is equal to 3. Then it becomes x squared plus 2x minus 3 is equal to 0. If you use PQ or ABC formula, you get x equals to 1 and minus 3. Okay, which one is acceptable, by the way? You see that this point has positive x value. The reason that you get a negative value, because this function is not one branch. One branch of this function is here, another branch of this function is here. So this is, indeed, you really have two intersection points, but the one that you are looking for is not this one. So I don't write this is a false root. It is indeed a root, but it is not visible because it happens, if you draw the graph completely, you will also see that intersection point. But this is the one that I am interested in. So this point is now understood to be 1. I need one more point. Can you tell me which point? I need this point as well. Yes? But this point is the intersection between this and the other line. Oops, I erased that. That line was x minus 2 given from the beginning. So I set up a system, y equals to x minus 2, y equals to 3 over x, and I do the same thing. So 3 over x is equal to x minus 2 this time. And if I calculate that, 3 becomes x squared minus 2x. And I move everything to the other side. And then if I use PQ formula, I get x equals to minus 1 and positive 3. But again, which one is which this one? The positive one. Because the negative one is here. And the reason is that if you have another branch, you will see another one. So here, this is acceptable. So this means that this number is now found to be 3. Now what I do, the total area is equal to the integral. I have to go from 0 to 1, but the area is between these two curves, between these two functions. The function above is x plus 2, minus the function below is x minus 2. Yes? Plus the integral, I go from 1 up to 3. The function above is this function, 3 over x, minus the function below is x minus 2. Yes? Any questions here? Okay, now if I ask you what is this, you can do it in your head. If I multiply minus sign in, it becomes minus x, and that x are totally gone. Minus minus 2 is 2, and 2 is 4. Yes? So it's very simple now. So let me just rewrite it once more. Integral from 0 to 1, 4 dx. Oh, sorry, 4, just 4. 4 dx. And then plus integral from 1 to 3. I multiply this negative sign in. It becomes 3 over x minus x plus 2. I continue here. If I continue, a primitive function for 4 is 4x, but I have to calculate it between 0 and 1. Then plus, okay, a primitive function for minus x is minus a half x squared. A primitive function for 2 is just 2x. But do you remember what is a primitive function for 3 over x? 3 is a multiplicative constant, so 1 over x. What is a primitive function for 1 over x? A function whose derivative is 1 over x is ln of x. Yes? So that's the exception. Be careful. So this becomes ln of absolute value of x, or x. In this case, you really don't need to bother about the absolute value because x is somewhere between 1 and 3 and it is positive. And then I have to calculate it from 1 to 3. I split this into two parts. I replace 1 here, it becomes 4. I replace 0 here, it becomes 0. I just split this one exactly the same. I put 3 here. And then simplify that. This becomes 12, 3 over 2. I put 1 here. ln of 1 is 0, of course, minus a half plus 2. ln of 1 is 0, 2 minus a half is 3 over 2. I go back to horizontal line, subtract these two, subtract these two. And then this becomes 4. This one and that one are gone. It becomes 3 ln of 3 area units. That's exact value of this area. Okay, so I really consider this lesson finished. So I think we can solve a lot of problems, but I think I've already talked about all the tricks that you might need in this. And then, as I told you, the next section is related to probabilities. For the time being, I skipped that one. I jumped to another application of integrals, which is now calculating the volumes. It's a little bit more fun than calculating areas, yes. And then after that, I come back and complete, and I want to recap a little bit of probability and then use that. Then there would be one chapter left, which is a very, very technical one and very important one, and that is the complex numbers. Okay, and then this course is finished. Goodbye, yes? Okay, any questions here? Okay, so I will pause, stop the recording here, thank you.